Before we look at some of the command on the Linux system, I want to go over some of the symbols that we have on the terminal. On the terminal, after username, we have colon, tilde, or some people call it tilde, and we have the $sign. Now, the tilde symbol represents your home directory. It lets you know exactly where you are on the file system. The $sign symbol is the shell prompt. It's specifically the default prompt for a regular non-root user, and it's available in most Linux distributions. Slash represents your root folder. So in the terminal, if I type the command cd/, this will take me to the root folder. And as we can see, the symbol has changed from a tilde to a slash. Now in that folder, if I do an ls, it will show me all of the files and folders that I have in this folder. Now inside of the root folder, we have the home folder, which represented with the tilde. Now in the home folder, that's where you can find my username, Nikki, in it. Now, it's always advised to not do anything in this folder if you do not know what you're doing, because you can change the way how your computer behaves. Now, if I want to go back into the home folder, which is this folder here, I can say cd and the tilde symbol, and this will take me back into the home folder. Now, if I do a pwd, it will tell me I am in the home folder, and in my home folder, I'm inside of the folder called Nikki init. Now, if I go back to the root folder, so I can say cd/ go to root, and I can say, show me what's inside of the home folder. And it will show me that inside of my home folder, I have another folder called Nikki init. Now, the next sign or the next symbol that I want to show is the dot. And the dot, when it's used in ls, it means hidden. But when it's used with cd, it means your current location. Right now, I'm using the up arrow and the down arrow to get the previous command. So I'm going to go back into the home folder. The command for that will be cd tilde. If I want to go back to the root folder, instead of saying cd/, I can say cd ... This will take me back to the root folder. So if I go ahead and hit enter, you see it takes me back to the root folder. So this is how this works in a nutshell. I'm going to go back into the home folder. So I said cd tilde. If I do a pwd, it will tell me that I am in /, which represents root. And instead of the root folder, I have a folder called home, which is this folder here. Inside of this folder, I have a folder called Nikki init. This is the current folder I'm in right now. Now, if I want to go back, one folder from Nikki init will be my home folder. So if I say cd ... you can see now I move to the home folder, because the home folder is the parent folder for Nikki init. So this takes me back one step up. Now, if I run the same command, cd ... it should take me to the root folder, which inside of the root folder have all of this folder. So if I go ahead and I hit enter, you can see it changed from home to the /. The first commands that I want to show are the basic commands, and these commands will let us know the date, the time, how to move around on the file system, how to know exactly where you are on the file system. The first command that I want to show is the date command, and the date command is used to display the date, time, and time zone. It also will display the year. The next command I want to show is the time command, and the time command tells us how long it takes for a command to be executed. The next command is the pwd command, and the pwd command will tell us where we are currently on the file system. So it means our present working directory. The clear command is used to clear your terminal screen. And when we hit enter, all of the command that we had previously is cleared. Now on the keyboard, we can use the up and down arrow to get to previous command. The cal command is used to display the current month calendar. Now when I hit enter, we're going to get a message saying command cal not found. So this have to be installed. To install cal on your Linux system, this is the command you would have to use. So we can go ahead and copy and we can paste it. So I'm going to go ahead and put in my password and it's going to install the packages. Now the packages has done installing. If I go back and run the cal command and hit enter, we get the month of February displayed for us. If you want to create a folder or a directory on the Linux system, the command to do that will be mkdir. Inside of the Nikki in IT folder on my right, I want to create another folder or another directory called Linux. To do that, I would have to use the command mkdir and the name of the directory that I want to create. So I want to create a directory called Linux. When I hit enter, I did not get back any error. If I go to the right and I refresh the file explorer, I should see the Linux folder inside of my Nikki in IT folder. Now, if you want to move into the folder, you have to use the command cd and the name of the folder. And when I hit enter, you can see now I moved from the home folder into the Linux folder. Instead of that Linux folder, I'm going to create another folder called auto. So I'm going to say mkdir auto, and I'm going to hit enter. Now, if I go inside of the Linux folder from the file explorer, I should see the auto folder. I'm going to keep the file explorer open for the next few tutorials just so you can see how files are created and removed and moved around on the system in real time. Inside of the auto folder, let's create a file. There are several ways to create files in Linux. You can use the cat command, the echo command, the touch command, the redirect command, and more. Later on in the course, we're going to take a look at these commands, but for now, I'm going to use the touch command. The touch command is used to change timestamps and access stamps in individual files or folders. If it does not exist, it will create one for you. However, it is often used to create empty files. So to create a file, you use the command touch. And I want to create a file called readme.txt. So I'm going to give touch readme.txt. And I'm going to hit enter. If I refresh the file explorer, I should see the readme.txt file inside of my folder. Now let's create another file called cars, and I'm going to say touch cars.txt and hit enter. If I refresh my file explorer, the cars.txt file should be in there. Now we can create multiple empty files by executing the touch command once and giving the touch command multiple files at the same time. So instead of writing the touch command twice, let's create two other files, but we're going to use the touch command once. So I can say touch, and I'm going to create a file called read1.txt, and I'm going to say cars1.txt. If you take a look at the command, I did not add any commas because Linux is smart enough to pick up the spaces between each file. Once Linux sees that there is a space, it would automatically think that I'm creating multiple files. I'm going to go ahead and hit enter, and I'm going to refresh the file explorer, and you should see my cars1 and read1. Another way to create file on the Linux system is by using the cat command together with the redirect operator. The cat command is also used to display contents of a file, which we are going to see later on. So I want to create a file called cars2.txt, and at the same time I'm going to input some text inside of cars2.txt. So I'm going to say cat, and the redirect operator is the greater than sign, and I want cars2.txt. When I hit enter, it should give me the screen to input my string. In here, I want to input the car Honda, and then I'm going to hit enter. I also want to include Mazda, enter, Chevy, enter, and last one, I'm going to say BMW, enter. To exit off the cat command, I'm going to hit Ctrl+C, and that will take me out. Now, if I refresh, I should see Cars2. Now, if I want to display the content inside of the cars2.txt, I can say cat cars2.txt, and it should show me all of the cars that I've entered or the text that I've entered in cars2.txt. Another way you can create a file on the Linux system is by using the echo command. Now if I say echo and I write something like hello world, and I'm going to redirect hello world into a file called myfile.txt. This symbol is called an operator. We call it the redirect operator, and it will redirect the standard output to the specified file. So it will take the output hello world and put it into the file called my_file.txt. So after running this command, a new file, myfile.txt, will be created in the current working directory, and its contents will be hello world. So I'm going to hit enter. If I refresh File Explorer, you should see my_file. If I get back the command, but instead of redirecting it into the output file, I can just show that text on the screen. If I hit enter, you would see hello world printed to me on the screen. A next way to create file is by using a text editor. So I can say vi cars.c. I hit enter, escape :wq and get out, or you can just hit Q to quit instead of saving the file, and I refresh the File Explorer. I should see cars.c inside of the folder. If you want to remove any files or directory on the Linux system, there are two commands you can use to do that. You can use rmdir or rm. Now let's take a look at rmdir. rmdir is used to remove the empty directories on the Linux system. So if I go back into my home folder, and if I do an ls, I have the Linux folder inside of my home folder. Now the Linux folder, it's not empty. So if I go back into my home folder via the File Explorer and I go inside of the Linux folder, I have the auto folder and other files inside of the Linux folder. If I use the rmdir command to delete this folder or directory, I should get back an error. So let's try it. rmdir, and I want to delete the Linux folder, and I hit enter. You would see an error saying rmdir failed to remove Linux directory, not empty. So the rmdir is used to delete empty directories only. So I'm going to go back into the Linux folder and I do an ls. I have the auto folder. I'm going to do a quick ls on auto, and if you don't understand what ls mean, I'm going to touch on it in a minute. ls just means list the file or folders that is inside of my current working directory. I'm going to hit enter, and you can see that there is nothing inside of the auto folder. So I can use the rmdir command and say auto and hit enter, and everything went perfectly fine. Now if I refresh the File Explorer, the auto folder is gone. Now if I want to remove a file, I can use the rm command. Let's delete cars1.txt. So I can say rm cars1.txt. You can see that cars1 is inside of the Linux folder when I use ls, and if I hit enter and I do another ls, you can see that cars1.txt is gone. If I refresh the File Explorer, cars1.txt is also gone. Now if I want to delete the Linux folder, or if you want to delete any folders that have content inside of it, the command will be rm-r. I'm going to go back into my home folder. I want to delete the Linux folder, and inside of the Linux folder we do have contents in there. So to delete a directory or a folder with contents in it, you use the command rm-r and the name of the folder, and the name of the folder in our case is Linux. If I go ahead and hit enter, I didn't get back any message. Now if I go back into my home folder, you should see that the Linux folder is gone from the side as well. And if I do an ls, we do not have anything inside of my folder. Now be very careful when you use the -r, because once you hit enter, you will not get it back. Clear command to clear the screen. On the Linux system, you can use the up and down keys to retrieve previous commands. So let's go back and create some of the files and directories. So I'm going to go back up and look for the mkdir command. I'm going to hit enter, which will recreate the Linux folder for me. So if I refresh the file explorer, my Linux folder is there. So if I go back and cd into the Linux folder, I'm going to use my up and down keys again to get the mkdir command for auto, and I'm going to hit enter. And if I do a refresh and I go inside of the Linux folder, my auto folder should be in there. So to make things easier for you, at times you can use the up and down key. However, I do encourage to rewrite the commands. That way the commands will stick with you. Now let's go inside of the auto folder. So I'm going to say cd auto. I want to create a file called cars.txt. So I'm going to say touch cars.txt, and I'm going to hit enter. I'm going to also create another file called read.txt. If I go into the auto folder, I should see cars.txt and read.txt. So if I go in from the file explorer and I go inside of the auto folder, I have two files, one called cars and one called read. Now I want to copy the read file and put it into the info folder. So to do that, I can say cp. I'm going to give Linux the path where I want to get the file from. So as we can see, the file is inside of the auto folder. So I'm going to say to the cp command, go inside of the auto folder, and inside of the auto folder, look for the file called read.txt. And I want you to take that file and put it inside of the info folder. Now, if I go inside of the info folder is empty. So inside of the terminal, I'm going to hit enter and I'm going to refresh the info folder. I have the read.txt file in there. The mv command is the primary tool for moving files and directories in Linux. It's versatile and can be used for both moving and renaming files. Now let's go inside of the auto folder. So I can say cd auto, and when you're on the Linux system, if you want to complete the command instead of writing it out, you can just hit the tab and the tab will complete it for you. So I'm inside of the auto folder now, and if I do a quick ls, inside of the auto folder, I have cars.txt and read.txt. I'm going to create another file called carinfo.txt. And if I do another ls, I can see the carinfo.txt. Now I want to move car_info into the info directory that we created previously. I'm going to go back into the Linux folder. I'm inside of the auto folder. I'm going to go back into the Linux folder, and the command to do that will be // which means go up one folder above. And I'm going to say mv. I'm in the Linux folder right now. So I'm telling the mv command, go inside of auto, look for car_info.txt file, and I want you to put it inside of the info folder. So I'm going to hit enter. If I go inside of the info folder right now, I should see car info and read. I'm going to go back to the auto folder, and you can see that the car_info.txt file is now gone. You can also use the mv command to rename files. Now if I do an ls on my auto folder, I have the read.txt file in there. Now I want to rename that file to readme.txt. So I'm going to say mv. I have to give mv the path to where to find the read.txt. So I'm saying to mv, go inside of the auto folder and look for the read.txt file, and I want you to rename it. So still inside of the auto folder, I want you to rename it to readme.txt, and I'm going to hit enter. Now if I run another ls on the auto command, instead of saying read, it has renamed it to readme.txt. The ls command allows you to list all files or directory in your current working directory by default. However, you can list files and folders from other directories once you provide the proper path. The ls command also accepts some flags called options, which are additional information that changes how files or directories are listed in your terminal. So for example, I'm inside of the home folder, and if I do an ls on that folder, it will only show me the Linux folder that we have created previously. Now, if I want to see all of the hidden files, I have to use the flag -a. So I'm going to say ls-a, and that will show me all of the hidden files that is inside of my home folder. Now, if I go over to the right, I can see that I have some files and folders, and a lot of the files and one of the folders start with a dot. Now, the dot means that these are hidden files inside of your folder, and these files should not be touched or manipulated. That's why they are hidden. Now, if I want to list files in other directories, I can do that as well. So if I go inside of the Linux folder from the File Explorer, you can see I have two other folders, Auto and Info. If I want to see what's inside of the Linux folder, instead of going into the folder and do an ls, I can do it from my home folder. So I have to provide ls the proper path. So I can say ls and list what's inside of the Linux folder, and it will show me auto and info. If I go over to my File Explorer and click on the Linux folder, I see auto and info. Now, I can also list what's inside of the auto folder from my home folder. And inside of the auto folder, I have two text files, cars and readme.txt. Now from there, I can give ls the path. So I can say to ls, go inside of the Linux folder, and inside of the Linux folder, display what's inside of the auto folder. I'm going to hit enter, and it brings back cars.txt and readme.txt. Now I can also list what's inside of the root folder from my home folder. So I can say ls, and the symbol for root is a slash, and I hit enter, and it will show me the files and folders that is inside of my root folder. If I go back to my left, Ubuntu, that is the root folder, and inside of the Ubuntu folder, I have a list of folders, and these are the folders that is inside of the Ubuntu folders. So if we look at all of these folders here, it's the same thing that is inside of the terminal. If I want to show a list of information, for example, the file permissions and the time the file was created and other information, I can do that as well using the -l flag. So I can say ls -l and show me the files inside of the root folder. And it will show me back all of the files with the permission, the timestamp, inodes, and so forth. If I go into the auto folder, so I can say cd, go inside of the Linux folder, and I want to go inside of the auto folder. I'm in the auto folder right now. If I want to list what's inside of the Linux folder, I can say ls // and // just means go up one step above. So one folder above auto will be Linux. So if I hit enter, it will list what's inside of the Linux folder. Inside of the Linux folder, I have auto and info. If we look at the information on the terminal, we have auto and info. Now I can go up one more step. So if I go .. that will take me from Linux to Nikki in IT. I'm going to hit enter, and inside of the Nikki in IT folder, if we go back, we have the Linux folder, which is displayed. Now, as I said previously, if I want to see all of the hidden files, I can just say ls -a. So -a means to show me all of the hidden files, and .. and hit enter, and it will show me all of the hidden files that is inside of the Nikki in IT folder. The cat command is a tool used for displaying the contents of a file. It is also useful for concatenating multiple files into one. Inside of the auto folder, I have a cars.txt, and if I open up that file, I have put in different car brands into this file. So I'm going to go ahead and exit off, And if I want to see the content of this file, instead of clicking on the file manually, I can say cat cars.txt and it will display the contents of that file. You can use the cat command to also create a new file, and when you use the cat command to create a new file, the terminal allows you to put content into that file right away. So I can say cat, and I'm going to use the redirect operator, and I want cars2.txt. When I hit enter, it's going to give me the screen to input the contents that I want inside of that file. So for cars2, I'm going to say Civic. Then I want CS3. I also want Bronco, and I'm going to say Cruise. And to get out from there, you can hit Control C and it will take you out from there. Now if I go back and I type in cat cars2.txt, you can see the list of models that I put into the file. You can also append data to a file. Now, inside of the cars2.txt, I didn't put any model for BMW. So I can go ahead and say cat, and I can give the redirect operator, which is 2 greater than sign. I can say I want cars2.txt, and it will give me the screen. Now I want to add 3 series. And I'm going to hit Control C, and if I run back the cat command for cars2.txt, I should see the 3 series added at the bottom. So you can append data, or you can append a line of text to the file using the redirect operator. I can also concatenate both files. So I can say cat, and I want cars.txt, and I also want cars2.txt. And you can see that it concatenates both files for me. The echo command is used to display text on the console or on the terminal. If I say echo, and inside of double quotes, I'm going to say hello world, and I hit enter, it's going to echo back hello world for me. Now you may ask, what's the point of that? When it comes to bash scripting, echo is a very useful tool. I can also redirect the output from echo into a file. So I can run back I can pull up back the echo hello world, and instead of printing it to the screen, I can tell echo put it into a file called my_file.txt. And echo will create that file and put hello world into that file instead of printing it on the screen. Now if I refresh, inside of the auto folder, I can see my_file. Now if I do a cat on my_file.txt, I should be able to see hello world. The find command is used to locate files and directories on your system that matches a given pattern. Currently, I'm inside of my home folder, and inside of my home folder, I have a Linux folder that contains an auto folder, an info folder, and an auto file. Now, if I want to find the auto folder, I can use the command find, and I have to provide a path for the find command. So I'm going to tell the find command to look inside of my current location, and the dot means current location. So I'm going to use the dot symbol to represent my current location. And inside of my current location, I want to find the name. So I must provide the name flag. And inside of single quotes, I have to tell the find command what name of the file or directory that I'm looking for. So I want to find the directory auto, and then I'm going to hit enter. The auto folder is located inside of the Linux folder. Now, if we go over to the right, I have an auto folder and an auto file. How do we know which auto Linux is bringing back? In this case, the find command is bringing back the auto directory instead of the auto file. Now, what happens if I want to find the auto file instead of the auto directory? Now, you can use the command find, and I will say dot still look in my current location, and I'm going to say dash type, and type just specifies the type of file that I want to search for. So I can say to the find command, find the type directory, and this will bring back the auto directory for me. And then I'm going to say -name and auto. So the command here just means look in my current location, find the type directory, which is type D. So D means directory, and look for the name auto, and it will bring me back the location for auto. Now let's try and find the file name auto. So instead of saying D, I'm going to say F, and it doesn't bring back anything for me. And the reason why it does not bring back anything for me is because the file have an extension .txt. So we must put some other characters to match that specific pattern. Now I can say asterisk. So asterisk means 0 or more characters. If I want, you can also put the asterisk in front. So the asterisk in front means to find anything before the keyword auto, and the asterisk at the end means find anything after the letter O. Now if I hit enter, it will bring me back Linux, and this time I get the auto file, which is the .txt file. If I want to locate all of the files in my current location that ends with .txt, I can do that as well with the find command. So I can say find, and I'm looking for files as well. So I'm going to say -type and specify files. And then I'm also going to give the -name flag, and then tell the find command what file do I want to find. Now I can say find me the read.txt file and hit enter, and it brings me back where the read.txt file is located. Now what happens if you have a readme.txt or you have a file underscore read? I can run back the same command, and if I don't know what type of read file is inside of my folder, I can specify and say match any file that have the word read and any characters before. So any characters before in this case will be file underscore, and the asterisk at the end will bring back the me, and also the read keyword in the middle will bring back the read file. So if I go ahead and hit enter, if I bring this over here, we are inside of the info folder, and inside of the info folder, if we look here, we have a readme.txt. We also have a read.txt. We have a file underscore read.txt. And if I go back into the auto folder also contains a readme.txt. If I want to find all of the files that have the extension .txt, I can just say asterisk dot and txt, and it will bring me back every file that has the .txt extension. If you want to search for files that are larger in size or smaller in size, you can also do that with the find command. Now, the flag to find file with specific size will be the -size flag. So let's say, for example, I want to find the files that is less than 100 megabytes. I can say find, look in my current location and search for any file, and I'm going to provide find the size flag, and I have to tell it what size do I want to search for. So I want to search for any file that has less than 100 megabytes, and I hit enter, and these files are less than 100 megabytes. So if we look at the results, so if I go back into my home folder, these files are in here. Now, if I want to find files that are greater than 100 MB, then I just have to use the plus symbol. And currently, I do not have any files that are greater than 100 MB in my directory. Now, I can also find files that has been modified in the last 24 hours. So I can say find, search in my current location, and look for the type file and find any file that has been modified less than 24 hours. So the flag for that will be mtime. And then I want to specify 1. And this command will tell me all of the files that has been modified less than 24 hours. So if I want to find the files that has been modified between yesterday and a week ago, I can say find, look inside of my current location, and I'm not going to specify a type because I also want to bring back the directories and files. So I'm going to say mtime, and I want it between yesterday, which is 1 day, and 7 days ago. So I'm going to say -7. And I'm going to hit enter, and it gives me all the files between yesterday and 7 days ago or a week ago. We can also find files that has been created at a specific time. So if I want to find files created more or less than a day ago, I can say find, and I want to find files and folder. So I'm going to say -ctime, and ctime just means time created, whereas mtime means time modify or modify time. So m means modify, c means create. So I want to find the files that has been created less than a day ago, and these are the files that has been created less than a day ago. Now if I want to find the files that has been created, so 7 days ago, more than 7 days ago, these are the files that has been created more than 7 days ago. grep is a tool in Linux that is used to search for specific patterns within a file or a text stream. Now, inside of my info folder, I do have a list of files, and I want to focus on the colors.txt file because inside of that file, I have a list of colors. So if I run the cat command on colors.txt, you can see my list of colors. Now, if you want to search for a specific color, you can do that with the grep command. So I want to search for the color red. So I can say grep, and inside of my double quotes, I'm going to say search for the color red. And you have to tell grep where to search for that color. So we have to tell grep, go inside of the colors.txt file and search for the color red. So if I hit enter, it will bring back red for me. Now, let's say you do not know exactly which file the color red is located. So we can say grep -r and the color red. And I'm going to put an asterisk. So it will tell me that red is inside of the colors.txt file. So the -r means to search anywhere inside of my current directory and all other subdirectories and look for the color red. We can search with grep and have grep ignore the cases of the word. So let's say, for example, I say grep, instead of single quotes, I want the color red, and I'm going to tell grep, look inside of colors.txt. grep would not bring back anything for me because inside of colors.txt, all of the colors start with a uppercase. So for me to bypass that, I can just use the -i flag, and -i just mean ignore case. And once I do that, it will bring back the proper results for me. If I want to bring back everything with the letter R, I can just simply say grep -i and just have the R, and it will bring back every color that has R in there. If I want to match any character that begins with R only, so I can say grep, and inside of the double quotes, I can put the caret. The caret means to start at the beginning or look at the beginning of the word. Okay, so match any character that begins with R. And if I hit enter, it will tell me red is the only color in there that begins with R. I can also change it and say instead of R, I want C. So any colors that begin with C, and it will bring back these two colors for me. If I want to bring back the colors that has R and C at the beginning, I can do this as well. So instead of just the double quotes, I can put a bracket. So it will be double quotes, brackets, and instead of having the carets inside of the bracket, I want the caret outside of the brackets. And inside of brackets, I'm going to specify R and C. So that means bring me back anything that starts with R and C. And it's going to bring me back red, cream, and coral. And I'm going to hit enter, and it brings back red, cream, and coral. I can also put the caret inside. So there's two different meaning of the caret depending on where you use it. The caret inside means do not include any colors that start with R and C. The caret outside the bracket means start at the beginning. So I'm going to go ahead and hit enter, and it brings back every color that does not start with R and C. The sort command is a powerful tool in Linux used to sort lines of text. It can sort based on various criteria such as alphabetical order, numerical values, or custom fields. I have a file called colors.txt. If I want to sort that file in alphabetical order, I can use the command sort, and I have to provide the path for that file to the sort command. So I'm going to tell the sort command go inside of my Linux folder, and inside of that Linux folder look for another folder called info, and inside of that info folder I have a file called colors.txt. and if I hit enter, the sort command will sort that file in alphabetical order. Now you can also reverse that order. So if I say -R, and -R just means reverse the order, and I hit enter, now the sort is reversed, so it will sort the file from Z to A. You can also sort the file in numerical order. So inside of my Linux folder, I do have another folder called auto, and inside of the auto folder, I have a file called cars.txt. Now let's sort this file in numerical order. So I'm going to say sort, go inside of the Linux folder. In that folder, I have a folder called auto, and then look for the cars.txt file and sort that file in numerical value. Now by default, it's going to sort it for me in numerical value, but there is a flag that you can use for numerical values. So I can say sort -n. Now inside of that file, it is not sorted. So if I do a cat on that file, so cat Linux, and go inside of the auto folder and cars.txt, if we look at the results, we can see that it is not sorted in numerical value. Let's display the cars.txt file again, and we can see that it's not sorted. Now, if I want to only sort the first field, which is the numerical value, I can do that by saying sort -k, and I have to tell the sort command which field do I want to sort by when I use the -k flag. So I want to sort the first field, go inside of the auto folder and look for cars.txt, and it will sort it in only by the first field. Now, if I want to sort only by the second field, I can do that as well. So instead of saying sort the first field, I will say sort the second field, and it will sort the name of the cars. If I hit enter, it sorts only by the name of the cars and not the numerical values. You can also sort by numerical values and by a specific field. So for example, if I run the ls-al to list all the hidden files, I can sort in a specific field. So if I count the number of fields, so this is field 1, field 2, field 3, field 4, field 5, 6, and 7. So I can provide the field number for the sort command. So I can say ls-al, and that means to list all of the hidden files for me in long form. And I'm going to use the pipe symbol, and the pipe symbol just simply taking the results of the ls-al command and put it into the sort command. We're going to learn about the pipe command in later videos. Then I can say sort and give the sort the flag nk. So that means sort the numerical values and the field number. So I want to sort field 7, and if I hit enter, if we look at the 7th field, we can see that it is sorted in numerical order. There are two types of path you can use to move around on the Linux system freely. You have the absolute path and you have the relative path. Now the absolute path always starts with a // and it contains the full path to a directory or a file. Now, let's say, for example, I want to display the content of a file called cars.txt, and that file is located inside of a folder called auto. The auto folder is located inside of a folder called Linux. The Linux folder is located inside of a folder called Nikki in it or Nikki in IT. And the Nikki in IT folder is located inside of my home folder. I know it's pretty long, and this is called the absolute path. Where exactly can I find this file? Now, let's say, for example, I want to display the content of that cars.txt file. Currently, I'm inside of my root folder. So I can say cat. Now, all these folders that I just listed is inside of my home folder. So I'm going to give the absolute path to the cars.txt. So I can say go inside of my home folder. And inside of my home folder, I'm going to have a folder called Nikki in IT. Now I can hit the tab to complete that for me. Instead of Nikki in IT, I have a folder called Linux. I'm going to hit tab again so it can complete it for me. And inside of the Linux folder, I have the auto folder. And then I want to display the content of cars.txt. And if I hit enter, I would get back the results from the cars.txt. Now, I can also put a / in front of home and hit enter, and I can still get the same results. So the absolute path is always with a /. So I can say /home/Nikki in IT /Linux /auto /cars.txt. This is the absolute path. Now, if I want to go inside of my Linux folder, I can say cd /home/Nikki in IT /Linux. And then I'm going to hit enter. And now I'm inside of the Linux folder. I can also use relative path to get around. And relative path is relative to my current location on the file system. Now, because I'm inside of the Linux folder, I have two folders in there called auto and info. I can say find, and I'm going to use the dot, and dot means my current location. So once I use the dot will represent my relative path. The dot tells the system I'm searching somewhere relative to my current location. My current location is inside of the Linux folder. Now, if I go ahead and tell the find command to search for a file, that's what -type is going to do, and look for all the files that have a .txt extension. And then if I hit enter, I will get back all of the files that have the .txt extension. In Linux, file permissions determines who can read, write, and execute a specific file or directory. Each file and directory has 3 types of permissions: read, write, and execute. The read permission allows a user to view the content of a file or list the content of a directory. The write permission allows a user to modify the contents of a file or add or delete files in a directory. The execute permission allows a user to execute a file, for example, a program file or a script. It can also give users access to files in a directory. The permissions can be set for the owner of the file, the group that the file belongs to, and all other users on the system, referred to as others. Now on my screen, I have letters in rows: RWX, RWX, RWX. So these are the read, write, and execute. So the first set would represent owner, which is you. The second set would represent group, and the last set will represent others. R, as I said previously, would represent read. So the person can read from a file. W represent write. The person can write to the file. And X represent execute. The person can execute a file. Now, each of the letters have an octal value. R octal value is 4. W octal value is 2, and X, which is for execute, octal value is 1. So in this case, the owner has an octal value of 4, 2, and 1. The group has an octal value of 4, 2, and 1. And others have an octal value of 4, 2, and 1. So that means the owner, the group, and others can read, write, and execute that file. Now let's look at the octal value a little bit more in depth. Numbers will represent the octal value. Permissions would represent the permission, and permission is also known as bits. And then you have the binary values for each permission together with their octal value. Now let's look at the owner. R, as I said previously, would represent the octal value 4. Now if we come down to 4, where it's on the number, we would see that the permission is R, which is correct. Now if we go to W octal value is 2. Now if we go down to 2 octal base, the 2 permission is W. Now if we look at the sign of W, the binary number is 0, 1, 0. For 4, the binary number is 100. X octal value is 1. And if we come down to numbers, we would see the permission for X is 1 and the binary value is 001. To get the permission of a file or to change the permission of that file, you have to add each of the values together. So for example, 4 plus 2 plus 1 will give you 7. Then the group has also the same value, 4 plus 2 plus 1, 7. Group can read, write, and execute that file. And others also have the same value as owner and group. 4 plus 2 plus 1, 7. Now, if we come down to the bottom, we have 7, which is read, write, and execute. 7, read, write, and execute. 7, read, write, and execute. If we run the ls-l command, it can show us the permission of a file or directory. So if I say ls-l, the D in front of the permission will let you know that that is a directory. The auto folder is a directory, and also the info folder is a directory as well. Now, a regular file will be represented with a dash. Once you see the dash in front of the permission, then you would know it's a regular file, and auto.txt is a text file. Now, let's look at the permission in depth. Let's take a look at the permission for auto.txt. Now, if I bring back up my screen, so if you see in the bottom here, for the auto.txt, we have the dash, which let us know it's a regular file. Then we have read, write, no execute power. And that is for the owner of the file. So if I bring this down, the owner does not have execute because there is a hyphen. So whenever you see a hyphen, that means you do not have that specific power. So for owner cannot execute this file, so there is a hyphen. So right now, the value is 4 and 2. Let's look for R on the chat, and R is 4, so we have 4. Let's look for W as well. W is 2, and then we have 2. So this section in the red is for the owner. Then we have the group. Now group has read permission only, and you see hyphen hyphen. That means the group cannot write or execute auto.txt. And then the last one will be others. Others only have read power. They cannot write or execute. Now, if we add this up together, we will get 4 plus 2 is 6, 4, and 4. If we look at the number chart, we have 6, and 6 will give us read and write power, and then 4 will give us read power for group and read power for others. If we're using the chmod command, the command will be chmod 644, and it will give us this type of permission. Now let's take a look at an example of permissions in the terminal. I want to create a hello.sh file. So I'm going to use the touch command to do that. So I'm going to say touch hello.sh. Now you can create any file you want. You can create a C file, a C++ file, or even a Python file, but just create a file where you can write code into that file. Now, if I go ahead and hit enter and I use the ls-l command again, I would see my hello.sh file with the permissions. So the permissions that I have is read, write, and no execute permission. So I cannot run that script. So I'm going to use a VI to write just a simple command into that file to execute. Now inside of my sh file, I'm just going to write a simple echo command. But before I do that, I need to tell my terminal where can I find that shebang. We're going to get into scripting in just a bit. So for now, inside of VI, I'm going to press I, and I means to insert or write command. And I want my shebang, so I'm going to say hash exclamation mark, and you can find my shebang in the /bin. So go inside of my bin folder, and then you would find my bash. And then I'm just going to say echo hello from bash, and I'm going to end escape :WQ to save and quit. Now, if I run this file, I will get permission deny. And to run this file, I can say ./hello.sh, and it says that bash hello.sh permission denied because I do not have execute permission. I cannot execute this file because the X is not next to the W for the owner. So in order to change that, you have to use the chmod command. If we go back to the PowerPoint, we want execute permission. So we already have read and write. So we're going to say 4, which we already have, 2, which we already have. Now we need to add 1 so we can get 7, which is execution power. So we're going to say chmod 7, and we want the group to have write permission and execute permission. So let's go back into the terminal and give another 7, and that 7 is for group. And if we go back to others, we can see that others has read permission only, and we want to give others execute and write permission as well. So we are going to add write and execute, which is 2 and 1. So that will give us 7. So if I go ahead and add 7 for group, so chmod 777 will give owner, group, and others execution power. So after 777, you have to give the name of the file. So I'm going to say hello.sh, and I'm going to hit enter. Now if I do another ls-l, if we look at the permissions now for hello.sh, you can see that it changed. So now owner, user, and group have execution power. So you can see this here and this here has changed, right? This has changed to this. So now I can go back inside of the terminal and run my script. So I can say dot, which means to look in my current directory or in my current location and execute the file hello.sh, and I hit enter, and we get back hello from bash. Here is the problem with the octal value 777. 777 is a very dangerous octal value to give to the chmod command. That means that anybody can read and write to a file, and this is very dangerous. You do not want to give a file full permission. So let's go ahead and take away some of the permissions for the hello.sh file. So we can use chmod, and we still want read, write, and execute power for the owner. So we're going to say 7. And for group and others, we want to change that permission. So we only want read permission for group and read permission for others. So we're going to say 4 to take away read and execute power for group and others. So we're going to say chmod 744 and the name of the file, which is hello.sh, and we're going to hit enter. Now if we do another ls-l, we can see now the permission has changed for group and others. A shell script is a text file that contains a sequence of commands for a Unix-based operating system. If you want to create a script, you can use the command touch and the name of the script. So I'm going to name my script test.sh. You can also use the vi command. So instead of saying touch, I can just say vi and the name of my script. Now when I use the vi command, it will automatically take me into the text editor once I hit enter. So I'm going to hit enter and I'm inside of the VI text editor. Once you're inside of the VI text editor, when you want to start writing, you have to press I, and the I means to insert text. So if we look at the bottom, we will see the insert keyword. Once you see the insert keyword in all caps, then you are ready to write your commands. Inside of your scripting file, you must start off with something called the shebang. And the shebang just basically tells the system or tells VI where to get your bash file. If you are on a Mac, your shebang will be #!/usr/bin/bash. If you're using Windows, then your shebang will be a little bit different. You just remove the env, and then the shebang will be /usr/bin/bash. Now, if I go over to my right and I go inside of the USR folder, you would see my bin folder. If I go inside of the bin folder and scroll down, you would see the bash file. When you finish writing your shebang, if you hit enter, you will go to a next line. When you want to write a comment inside of your script, you will use the hash symbol. So I can say this is a comment, and when I run my script, this line will not be executed. So let's write a simple echo command. So I'm going to say echo, inside of double quotes I'll say hello learners. And when you want to exit off your script, there are two ways you can do that. It's either you save the file or you just quit the program. So in order for you to save the file, you can hit escape : and WQ will save and quit the program. Now that we're back in the terminal, I want to run the script. But before I run the script, I have to give execute permission in order to do that. So if I just run /test.sh, it will tell me I do not have any permission. So I want to add execute permission to that file. So I'm going to say chmod 755 and the name of my script. So the name of my script is test.sh, and I'm going to hit enter. Now I can go back to the previous command and run it, and I get back hello learner. There are two types of variables in scripting. You have system variables, and these variables shape the working environment when you log in. Example, pwd, home, path, host, user, shell, etc. If you want to see a list of variables on your system, you can use the command env and hit enter, and it will tell you your system variables. So you see we have shell, name, pwd, log name, home, etc. And you also have the user-defined variables, and the user-defined variables are variables that are created by the user. So let's use back the test.sh file. So I'm going to say vi test.sh, and inside of the text editor, let's create some user-defined variable. So I'm going to delete the echo statement, and I'm going to give two variables. The first variable will be first name. So I'm going to say first_name, and I'm going to have that equals to Nikki. The second variable will be last name, and I'm going to assign it to NIT. And I'm going to run an echo statement. So I'm going to say echo, hi, my name is. And if you want to use a variable in your script, you have to use the $sign. So I'm going to say $sign and the name of my variable. So I'm going to say first name. And when I used a variable in my script, you can see that it changed colors. So that will also show you that you are using a variable that you have created. So I'm going to say first name, $sign, last name. And then I'll say, I am a developer. Now after this, I'm going to hit escape WQ to save and quit. And then I'm going to run the file test.sh, and it should bring me back, hi, my name is Nikki in IT. I am a developer. These two words are variables that I've created. So this is the first underscore name variable, and this is the last underscore name variable. You can also run environment variables in your script. So if I go back into VI and under the echo statement, I'm going to create another echo statement, and I'll say my current location is, I'm going to use the PWD variable. I'm going to hit escape WQ to save and quit. And I'm going to run the script again. And in the bottom, the second echo statement, it says my current location is /home/Nikki in IT /Linux. And if I run the PWD command from the command line, it will give me back my current working directory. A positional parameter in Linux is simply a numbered variable that stores the arguments passed to a shell script or a function. So the numbered variables are $1, $2, $3, all the way up to $9. However, you do have some symbols that can be used to bring back a specific value when you are using these positional parameters. For example, $@, $$, hash, $question mark, and so forth. Positional parameters are best used in scripts, but I'm going to use it on the terminal using the set command, which will be a little bit easier for you to understand. So I'm going to say set, and I'm going to set a list of names. So I'm going to set John. I want Sally, Mike, James, Kirk, and Mike. So these are the names that I want to set. Now, John will be positional parameter 1, and that will be represented with a $1. Sally will be positional parameter 2, that will represent with $2. Mike will be positional parameter 3, that will be represented with $3, and so forth. Now, when I hit enter, it's going to set it for me. I can use the echo command to print specific values. So if I say echo and I want to print $1, that will bring back John. Okay. If I do echo print $2, that will bring back Sally. If I do $4, that will bring back James, right? So this is how positional parameter works. Now, if I want to print everything, I can say echo $@ and that will print everything, all the names that I've set. Echo $**, and that will print everything for me as well. If I want to print all the numbers of the positional parameter, I can say $hash, and it will tell me I have 6 positional parameter. I can also print the current process ID. Okay, so I can say $, and it will give me the process ID for these positional parameters. Now, when you are using it in a script, it will make more sense. So for example, if I create a script, I say vi and I say test pause.sh and I hit enter. Now I'm going to add my shebang /usr/bin/bash. I can say echo first name in the list. I can use $1. So $1 will give me the first parameter. I can also say echo second name in the list, and I can say $2. And for the last one, I'll say echo third name in the list, and that will be $3. Now, if I hit escape WQ to save and quit, then I'm going to give permission to this file. So I'm going to say chmod 755 test pos.sh, and then I can run test pos.sh with multiple names. For example, I can pass John. I can also pass Sally. I'm going to pass Mike. And if I hit enter, it will tell me the first name in the list is John, which is here. The second name in the list is Sally, which is here. The third name in the list is Mike, which is here. The if statement allows the ability to make decisions like any other programming language. If this happened, then do this. If this happened, then do that. Let's create a new file inside of the Linux folder, and we're going to call it iftest.sh. So I'm going to use the touch command to complete that. So I'm going to say touch iftest.sh, and right away I'm going to give the file some permission. So I'm going to use the chmod command, and I'm going to use 755 and the name of my file. Then I'm going to use vi to open this file. So I'm going to say iftest.sh, and I'm using tab to complete, and inside of vi I'm going to use I for insert. That way I can write. Now the first thing I want to do is give the shebang. So I'm going to say pound exclamation /usr/bin/bash. I'm going to declare a variable, and I'm going to call this variable color, and I'm going to assign that variable to $1, and $1 means parameter. So this is going to be the first parameter when I run my script. Now for the if statement, I can say if, and when you use the if statement, you must give a space. In other programming language, they're not so strict on space, but when it comes to scripting, you have to give the proper space. So if I do this, it's going to result in an error. So I have to, after the if statement, give a space and then give an open bracket. Then I'm going to call my variable. So I'm going to use the $sign and the name of my variable. So I'm going to say color, and I'm going to give another space, equal sign, and I'm going to declare my color as green. And then I'm going to give a space and then the bracket. Pay close attention to the spacing. If you miss any space, your program is going to give an error. Then I'm going to say, then I can just echo and say right color. And I'm going to close my echo statement. And then I'm going to go to the bottom of the echo statement, and I have to let the system know that this is going to be the end of my if statement. So once you finish writing out the if statement, you can use the statement fi. So fi means done. So I'm going to get out of vi by hitting escape, WQ to save and quit. And on the terminal, I'm going to call my script. So because I already give the script permission, I'm going to say / and iftest.sh. Now, when you are running your script, because we put the positional parameter as 1 or $1 on the command line, we have to give the script a color. So I'm going to say green, and green was the color that I assigned the color variable to. So I'm going to go ahead and hit enter, and it says right color. You can also use the test keyword, and let me show you how to do that. So if I go back inside of vi, and instead of saying if with a bracket, I can remove the bracket and I can say test. So that means to test the value that is coming in through the parameter. After you're going to delete the bracket at the end. So I'm going to go ahead and hit escape, WQ to save and quit. Now if I run back the same command with the green parameter, I should get the same answer. So just keep in mind that the test and the bracket, the open and closing bracket, they are equivalent when it comes to scripting. So you can either use the open and closing bracket, or you can use the test keyword. For the if statement, you also have options. And a couple of the options is -e to check if a file is available, or you have -d to check if a directory available. You also have -gt for greater than, -lt for less than, -eq for equals. So let's look at a little bit of the options. Let's go back and use the iftest.sh file, and we're going to delete what's inside of the if test file. Before I hit I, I'm going to hit double D to delete the line. Now, let's create a file variable. So I'm going to say file in all caps, and I'm going to have it assigned to $1, which means the first parameter. Then I'm going to say if with a space, open bracket, -e, and after the E, I'm going to call my variable. So I'm going to say $file, and I can either call my file like this, $file, and end the bracket, or I can put the file variable inside of curly braces. Most programmers prefer to put the variable inside of the curly bracket to prevent ambiguity. So after my if statement, then I'm going to say then. After the then statement, I'm going to give an echo statement to say, if the file is there, I want to print to the console file exists. And then I'm going to end my echo statement with the double quotes. After the echo statement, I'm going to say else, right? So if the file is not there, then I want to print to the screen echo file does not exist. And after the last else statement, you have to let the system know that this is going to be the end of my if statement. So I have to use the statement fee. So I'm going to hit escape :WQ to save and quit. Before I run the script, I'm going to give a quick ls in my current working directory, and you can see that we have an auto folder in there. So I'm going to say ls auto, and inside of the auto folder we have a cars.txt file. So let's try to run our script with cars.txt file to see what results do we get. So I'm going to say /if-test.sh and check to see if cars.txt is available inside of my current working directory. Now pay close attention. It says file does not exist because the file is not inside of the Linux folder. So if I do an ls, it's no way inside of the Linux folder. The file is inside of the auto folder. So I have to give the full path to this file. So I can come here and say auto/cars and hit enter, and then it says the file exists. Also say cars1.txt. We do not have a cars1 inside of the auto folder. We have cars2. So if I run cars1, it should say file does not exist. Now if I run cars2 inside of the auto folder, then it says file exists. Let's check to see if a directory exists. So I'm going to go back inside of VI, and I'm going to say vi if-test.sh, and instead of using -e, I'm going to use the -d flag. Let's change it to dir. We are also going to change the variable name to dir instead of file, and we can just simply say dir exist, dir does not exist. So I'm going to hit escape :WQ to save and quit, and I'm going to run the script, and this time I'm going to check if the auto directory is inside of the Linux folder, and it says dir exists. Now if I check if auto1 exists, it's going to say dir does not exist. Let's go ahead and test some of the comparison options that we have. I'm going to create a variable called num1, and I'm going to have num1 assigned to parameter 1. So I'm going to say $1. Then I'm going to have another variable, and I'm going to call this variable num2. I assigned my num2 variable to 20. Then I'm going to have my if statement. So I'm going to say if space bracket space $num1, and then I'm going to use the -GT, and -GT means greater than. So if the value that the user input is greater than 20, $num2 space close off bracket, I'm going to hit enter, and I'm going to give the then statement, and I'm going to say echo $num1 is greater than $num2, and I'm going to close off with my double quotes. Then I'm going to go on the next line, and I'll say else echo $num2 is greater than num1. And I'm going to close my echo statement with the double quotes. And I have to let the system know that I'm ready to end my if statement. So I'm just going to say phi. Now this statement is pretty simple. All we're doing here is we check in if num1, which is this variable here, we check in if this variable is greater than 20, which is num2. And if it is greater, then we're just going to print the echo statement that num1 is greater than num2, else we're going to say num2 is greater than num1. So I'm going to hit escape, :WQ to save and quit. Then I'm going to run the file and I'm going to give the number 10. And it says here 20 is greater than 10. I'm going to run the script again and then I'm going to give it 30. And it says here 30 is greater than 20. Now let's try less than. Okay, so instead of saying GT, we're going to say LT, and LT means less than. Let's change the echo statement to less than. So instead of saying greater, we're just going to say less. And let's come back down here and change this to less as well. Escape, :WQ to save and quit. Now let's check if 30 is less than 20. I'm going to hit enter and it says 20 is less than 30. Let's give a higher value. Instead of saying 30, I'm going to say 90 and it says 20 is less than 90. Let's try one more. And instead of saying 90, I'm going to say 10 and it says 10 is less than 20. You can also perform multiple checks using the if statement. elif lets you check for different expressions. There are some rules when it comes to the elif statement. The elif statement must come before the else statement. The else statement should be the last statement right above the phi statement for the if statement. Now let's see how this works. So this echo statement is for the then, and this echo statement is for the else. Now let's add the elif statement. As I said previously, the elif must come before the else. The else has to be last. So right under the echo statement, I'm going to say elif, and for elif, we want to perform another check. We want to check if $num1 is equals to, and for equals to, we use -eq. So if num1 is equals to $num2, then we want to print an echo statement for that elif statement. Then we have to give the then statement, and after the then statement, we're going to write our echo statement. So we can say echo $num1 is equal to $num2. So let's go ahead and hit escape, :WQ to save and quit. And let's run back the script with 20. We hit enter. It says 20 is equal to 20. Let's run back the script again. This time we're going to enter 10. 10 is less than 20. Let's run the script again with 100, and 20 is less than 100. A while loop in Linux, specifically in Bash, is a control structure that repeats a block of command based on a given condition, or as long as the condition is true. For example, we can say while 5 is less than 6, then do this. Let me give an example. I'm going to create a file called while.sh, and I'm going to use the touch command to do that. So I'll say touch while.sh. Right away, I'm going to give permissions to this file. So I'm going to say chmod 755 while.sh. Then I'm going to use vi to open while.sh, and inside I'm going to hit I, and the first thing I want to do is put in my shebang. So /usr/bin/bash. Now inside of my script, I'm going to create a variable called count. So I'm going to say count equals to 1, no space in between. Bash is very sensitive. If you do put a space for assigning values to a variable, you will get an error. And then I'm going to say while space brackets space, and I'm going to call my count a variable. So I'm going to say count and -le. So this option I'm going to use right now is less than equal to. So I'm going to say while count is less than equals to 5, I want to do something. So I must put the do statement. Remember, for the if statement, we had if, then. For the while statement, we have while, do. I want to print, so I'm going to use echo, and I'm going to say count, and I'm going to call my count a variable, and double quotes to end. Now I want to increment my count value. So I'm going to say count now is going to equals to $, inside of double open and closing parentheses. I'm going to say count plus 1. And count plus 1 just simply means that when you execute the first while loop, increment the count value. So if count is at 1, then go up to 2, then go up to 3. After that, we have to end our while loop. So when it reaches 5, it's going to stop and end the program. So we must put the done statement. So to go over the code, we created a variable called count and we assign it to the value 1. Now, while is a loop. So this loop is going to keep executing repetitively. Right now, count is at 1, so it's going to print 1 until it reaches 5. In other programs like C++, you will see count plus plus. So I'm going to hit escape :WQ to save and quit. Then I'm going to run my script. So I'm going to say /while.sh and hit enter. And you see here it bring back count 1, 2, 3, 4, and 5. I'm going to clear my screen and then I'm going to go back into VI. Instead of using count, let's use something that is used in the real world. I'm going to hit D to delete each line, and we're going to check if a file exists, then we want to print whatever is in that file. So we're going to do a check and then we're going to print. So I'm going to declare a variable called file. I'm going to assign file to $1. And then I'm going to say while, and for my while loop, I'm going to check just as how we checked for files in the if statement. So I'm going to say -e, and that means if a file exists. We're looking for a file. So we're going to say E. If we're looking for directories, we will use D. So I'm going to say -e, $, I'll call my file variable, and I'm going to close off with the bracket. Now remember, spacing is very important in Bash. Now after the while, we must say do. And this time I'm going to introduce a tool called awk. We're going to get into awk later on, but awk is a very, very powerful tool in Linux. And we're going to use awk to print whatever is in the file. So I'm going to say awk in single quotes, and inside of curly brackets, I'm going to use print, close it off, single quote, and I want to tell awk to print what's inside of that file. So I'm going to use my file variable. Then I'm going to use the break keyword. So what that is going to do is going to break out of the loop once that action or once that command is done. Then I'm going to say done. I'm letting the system know that this is the end of my program. Then I'm going to hit escape :WQ to save and quit. After that, we're going to run the program or run the file, and we want the file that's inside of the auto folder. So we can say go inside of the auto folder and look for cars.txt and hit enter, and the program printed whatever inside of cars.txt. Now if I do a cat on the cars.txt folder, you can see that we got back the same result. A for loop in Linux lets you run a block of command repeatedly over a list of items, numbers, files, or command outputs. Let's take a look at an example. Inside of my Linux folder, I'm going to create a file called for.sh. And right away, I'm going to give permission to that file. So I'm going to say chmod 755 for.sh. Then I'm going to use VI to open up this file. So I'm going to say VI for.sh. And right away, I'm going to put my shebang. So I'm going to say /usr/bin/bash. To use a for loop, you must use the keyword for, and we are going to create a variable inside of the for loop. So I'm going to say file and file is a variable that I created myself. You can call this variable whatever you want. So I'm going to say file in, and I'm going to search for specific files. So I'm going to say star.sh. So I want the for loop to look for any file in my current directory that ends with .sh. You can also change it and look for .txt. So in this example, I'm going to look for .sh files. So the star mean or the asterisk means to find anything before .sh. And then we're going to use a do statement. So we can say for file in any file that ends with .sh. When you find this file, this is what I want you to do. So I want to print, and I'm going to use echo to print, and I'm going to say found, and I'm going to call my file variable. So I'm going to say $file. The file variable is declared inside of the for loop. And at the end of the echo statement, on the next line, I'm going to say done. So I'm going to hit escape, WQ to save and quit. And then on the terminal, I'm going to run the for.sh. So I'm going to say for.sh. This is how I'm going to run my file. And then when I hit enter, it will say func4.sh, hello.sh, hello func.sh. So all the files in my current directory that ends with .sh. Now if I do an ls on my folder, you can see all of these files in here. So all the files that is green, these are all program files or bash files. You can also use the for loop in Linux in a C style syntax. So I'm going to delete these lines. And then for the for loop, instead of saying for file in, I'm just going to do this. I'm going to say for in space. I'm going to give two open and closing parentheses. So instead of open and closing parentheses, I'm going to say I. I is just a variable that I declared myself. So I is going to equals to 1, and then you have to put the semicolon. Then after, I'm going to say I is going to be less than equals to 5, then semicolon and I++. This means start at 1, then go through the loop until you reaches 5, and at the end we are just going to increment I. So I is like a counter. Then after, we're going to come down at the bottom, and we're still going to use the do keyword, and then we're going to say echo, and for echo we're going to say number, and we're going to call our I variable. And then we're going to come at the bottom and say done. So I'm going to hit escape, WQ to save and quit. And then I'm going to run the script again. And when I hit enter, it says number 1 all the way up to number 5. A function is a block of command that carries out a certain task or activities. In other programming language, it will be a block of code. But when it comes to Linux, it will be a block of command. A function breaks down large programs into smaller programs. With functions, you can reuse them in your script by calling the name of the function without any parameter. And a parameter is the open and closing brackets. So there are some rules when it comes to function in Bash. So in other programming languages like Python, C, C++, Java, you would have to use the return 0. In Bash, you do not use a return value to the caller. Its return value is its status when the function ends. So there are 3 ways you can write a function in a Bash. You can write a function using the open and closing parentheses together with the open and closing curly braces. You can also use the function keyword in front of the function name together with open and closing brackets and open and closing curly brackets. The last way you can do it is by using the function keyword in front of the function name, and you can remove the open and closing parentheses or the open and closing brackets. However, you have to leave the open and closing curly brackets. Now, with a function call, you must call the function after the closing curly brackets. I'm going to create a script called hellofunc.sh. I'm going to use the touch command to do that. So I'll say touch hello func.sh, and right away I'm going to use chmod to give permission to that file. So I'm going to say chmod 755 hello func.sh, and then I'm going to use a vi to open hello func.sh /usr bin/bash. Then I'm going to come down and write my function. So there are three ways you can write the function. I'm going to show you the first way. My function is going to call hello, and then I have open and closing parenthesis. And this open and closing parenthesis, this is called the parameter. And inside of the hello function, I'm going to write my command. Now the open and closing curly brackets, this is a must for functions in Linux. Now inside of the open and closing curly brackets, that's where you're going to write your command. So I'm just going to write a simple echo statement inside of this function. So I'm going to say echo good day, and I'm going to take some data from the parameter. So I'm going to say $1 and $2, and this is going to be all for this function. After the function body, you can come to the bottom of the function and say hello. You're going to give some information for parameter 1 and parameter 2. So I can say hello Mary. For the second parameter, I want John. And that's it for this function. So I'm going to hit escape WQ to save and quit. And now that I'm back on the system, I'm going to call this function. So I can say /hello func.sh and hit enter, and it says good day Mary and John. I'm going to clear the screen and go back into VI. The second way we can call this function is by using function keyword before the function name. Now I'm going to hit escape WQ to save and quit, and then I'm going to call back my function again, and I still get the same result. I'm going to go back into VI, and the last way you can create a function is by removing the open and closing parenthesis. Hit escape WQ to save and quit, and then I'm going to come back and run the script, and I will still get the same results.